and we're on. Okay. So thank you everyone for joining us this evening. Looks like we have a good turnout and we have a few people here at the center as well joining us. So thank you again. Good evening and welcome to another episode of the Wild Sheep webinar series. I'm Amanda Verheuel, the Executive Director of the National Bighorn Sheep Center, and our mission is to provide education and outreach for the national conservation of wild sheep, wildlife, and wildlands. I would like to thank our partners and viewers for your support. Appreciate you all coming here today, and this will be recorded and available at a later time on our YouTube channel as well as on our website. Tonight in our Wild Sheep webinar series, I'm excited to present the relationship between bighorn sheep age, horn curl, and regulated harvest. Our first panelist this evening is Mr. Grant Chapman. Grant is the provincial big game specialist within Alberta's forestry and parks, hunting and fishing branch located in Alberta, Canada. Grant has an MSc specializing in big game ecology from the University of Alberta and has been with the GOA for more than 19 years. He currently oversees a team responsible for most aspects of provincial big game ungulate species management and has a keen interest in bighorn sheep. He's currently involved with several collaborative projects with the Wild Sheep Foundation of Alberta, public stakeholders, NGOs, universities, government departments, and national parks. Part of his role involves managing the sheep registration program and species management planning, which enables a unique opportunity to collect and analyze long-term data sets involving horn age, curl, and regulated hunting, which has been in place for more than 70 years. Our second panelist this evening is Tayler LaSharr. Tayler is an ecologist whose interest is in the natural world, largely driven by her desire to understand what influences animal behavior, decision-making, and how they spend their energy. Much of Tayler's work has been focused on how weather influences survival and reproduction of mule deer and how hunting influences population dynamics and horn size in big game species. Her interest in ecology is closely tied to her interest in collaboration and producing science with others. All of her work is largely collaborative and would not be possible without a team of people with multiple and diverse perspectives and ideas, which allows for more nuanced decision-making in the management and conservation of wild animals. She is currently a postdoctoral research scientist with the University of Wyoming and is based out of Logan, Utah. Any questions or comments before we get started? And just kind of a reminder to mute yourselves as Grant and Tayler are speaking. Okay, without further ado, I would like to hand it over to Mr. Grant Chapman.
Excellent. Thank you, Amanda, for the invitation to share with you some of the exciting stuff that we're working on in Alberta. This is a collaboration that's involved many contributors, and over the last 70 years, we've been collecting this sort of data. It's certainly many before me have been involved, and we continue to improve. So excited to share with you an insight into some of those improvements. So everything's working with screen sharing and voice?
Yes, thank you, Grant.
Yeah, so I'm the provincial big game specialist in Alberta. Currently within Forestry and Parks Hunting and Fishing Branch, we oversee all aspects of game management planning, licensed hunting, allocation, harvest, stakeholder engagement, and many other aspects of the big game program. And within this presentation, we'll talk about some background objectives, methods, results for a couple of the objectives, and then have a bit of time for discussion. I've got about 20 minutes prepared here, and I think, Amanda, you can either have the questions and prompt me or save them for the end or save them for the question period after Tayler's had her opportunity to speak. I'm flexible with either. So looking back at the history of Alberta, bighorn sheep hunting regulations, the first big game biologist for Alberta William Wishart, 1956, did his master's degree, and that was in the Sheep River area of Alberta, and he attempted to describe the relationship between horn curl and age at that time, and we have and other after him have also been very interested in the topic. Tayler, 1962, in Montana State University in Missoula, there also did some early work on bighorn sheep, and some of this related to a horn curl based regulation evolution of regulations throughout the decades. Wishart finished his thesis in '56, and shortly after that, we converted from a general tag that allowed for any ram over 1 year old to be killed, to then be more restrictive to a 3/4 curl age objective. And then in 1968, that further changed to a 4/5 curl or trophy sheep regulation. And in 1996, some regulations in southern Alberta for a few WMUs, wildlife management units, converted to a full curl regulation, as illustrated by some of these figures on the bottom. Throughout that time period, compulsory registration commenced in 1968, whereby hunters were required to bring their animals in, and in 1985 we began plugging those, consistent with many other jurisdictions in North America. Also informing management of wild sheep in Alberta is the 1993 management plan, which is the current draft. So when I took over sheep management and became significantly involved in about 2014, and then more in a major role in 2019 and onwards, I was asked to critically review a 2015 draft of the management plan and understand how the horn curl regulations related to management objectives, and how that those objectives aligned with the regulations. And we were a bit challenged to do so, surprisingly. So, and there were some issues along the way. The horn curl based harvest system that's in place in Alberta typically harvests mature males and maintains an age objective in the population that now we're able to describe both in time and space, and how they vary throughout Alberta, with some enhanced protocols that we're using to measure. That results in a hunter success rate of about 5% for over-the-counter licenses. We have issued just over almost 3,500 licenses historically, and in the last 4 decades, those hunter participation in bighorn sheep hunting has declined by approximately 1,000 hunters. So we're in the range of about 2,500, 2,200, 2,300 licenses annually, and with a 5% success rate. Our non-resident aliens, they are outfitted in the province, and I believe there's about 85 allocations held by our outfitters, and they have about a 50% success rate. And we've had a very high level of compliance using these horn-based regulations in Alberta, with very few non-compliant sheep occurring annually, with a harvest of about anywhere from 150 to just over 200 rams per year, varying through the years with difference in survival and lamb crops, etc. So with that, this resulted in a registration database. Today, we have about 9,900 rams in this database, is one of the things that we estimate. And of those rams, there's about 9,700 that are aged using horn annuli aging techniques to estimate those age. We do not do any cementum annuli aging in Alberta, but throughout most of this period, we collected age, length, basal circumference, location, and a few other data attributes. When I became involved with the sheep management program, the previous sheep specialist for Alberta, John Jorgensen, indicated that there was a high error rate in aging sheep, that it was, he estimated that it was plus or minus 2 years. So the confidence in the reported age of these 9,900 rams varied significantly for a variety of reasons, mostly related to lack of historical training in how to age sheep accurately. And so in 2019, we realized this and wanted to improve our measuring protocols to ensure that we were able to quantify management objectives and relate them to age and size structured harvest. And so since 2019, we have introduced a new horn measuring protocols, and to date we've had about 962 rams registered, of which there's 951 of those that are aged. In addition to this, we've also, I won't discuss it much, but we've in 2021 we published an externally available updated bighorn sheep registration procedures and have given many public presentations ensuring that that hunters were aware of where each of these horn-based regulations fall, and to ensure that they're compliant and understand those. So within this project, our objectives were to more accurately describe and compare ram horn growth rates and model the outcomes of these harvest strategies to management objectives, and further the use of this information by estimating ram harvest rates with integrated management systems and population modeling capabilities. Fortunately, the Canadian Mountain Network, produced an exceptional guide to aging mountain sheep a few years ago, which has enhanced our training tools. And so we have retrained. Formerly, we had about 150 staff involved with sheep registrations. Now we've limited that to about 20 staff and only 13 offices, which has really enhanced the skills and competencies of our wildlife biologists that are involved with registration. So what did we do in addition to extensive training and retraining, standardization, improvement of forms, provision of tools and equipment to help folks collect these measurements? There's annual training that occurs, and if folks are not trained to the new protocol, they're not permitted to be involved with the registration. So we collect age, which was standard, but we collect the length of every annulus on the longest horn. We collect the diameter of curl, the tip to tip, the base to base, which enables us to create three-dimensional images or models of the horns. And then we also accurately defined where the regulations fell in relation to curl for 3/4 curl, 4/5, and full curl. And then we measure the horn tips relative to those locations, which are consistently gathered, so that we could describe these in 2 or 3 dimensions. We also collect the basal circumference, and new for 2024, we started collecting Boone and Crockett scores to help also understand, scoring systems and how they relate to the size structure of the sheep that are being harvested. What does that enable us to do? Well, it enables us to, for the first objective, to describe and compare horn growth. And we found that the mean age of a 4/5 curl ram, or a trophy sheep regulation, is about 6 years old. And the mean length of that sheep is about 30 inches or 76 centimeters, which, when you convert to a proportion of a curl, is about 84% of a curl. And so the figure here has a lot of information within it, but on there we've got the hashed line, the lower hash line indicated by 3/4 curl. That curl is actually, in a theoretical proportion of a curl, is just over 82%, I think, is the proportion, whereas the 4/5 curl regulation is interpreted to be about 86% of a curl, and then the full curl regulation isn't actually full curl; it's about 92% of a curl. And so most rams under the 4/5 curl regulation would achieve that. About half of those rams achieve 6 years of age, achieve 4/5 curl by 6 years of age. And so within this image here, we have 733 rams in each of these that have been remeasured in recent years to estimate the distribution of horn growth in relation to curl, and in the relation to both proportion of curl and to the regulation. So, and of course, age on the bottom here. So it enables us to estimate the logistic regression of horn growth by age, but also the figure on the bottom right illustrates the confidence intervals, 95% confidence intervals for sheep grown in different ecoregions of Alberta. And with the area indicated where my cursor is here, the actually fastest growing sheep in the province in the Catamount area. And when I say fastest growing, it's not an overall length, it's fastest growing in proportion of curl, and proportion of curl is a function of the diameter of curl of that horn. So a horn that is, let's say, 76 centimeters, if the diameter of the curl of that horn was, let's say, a couple of centimeters smaller in diameter, it's about a 1-to-3 ratio. So if a sheep horns in Alberta range from about 23 centimeters in diameter to 37. And so a sheep with a 37 centimeter curl, as opposed to one that is 24, would be 13 centimeters larger in curl diameter, which would result in 39 centimeter longer horn to achieve the same horn curl. And so but typically this illustrates that the fastest growing rams have the greatest opportunity for harvest and will be harvested first in a population. And historically, when we remeasured some sheep in the province, we're still seeing that there is an aging error that's biased, and that historical ages were typically 1 year older than our current aging estimates, and that in some samples, up to 66% of those animals were incorrectly aged. So analysis based on historical records wouldn't have been able to adjust for any error, but now we're able to describe more accurately than ever before what these relationships look like. So how do we use this to inform management? When we use the use this information, we can develop a population structure model using growth rate, harvest rate, and non-hunting mortality to estimate not only the yield of rams in any particular region, but also the age distribution of the expected harvest under that regulation. So what does this look like with, I should stress that these are preliminary results and that the analysis are being refined so these are preliminary results that I'm sharing with you. These are not final results. So in practice, if an age distribution of a 3/4 curl regulation would yield about 200 rams per year, and the age distribution is slightly shifted left, with the first legal rams being harvested at 3 and the oldest potentially out to 15, but with the mean age somewhere in the 5-year range, whereas a 4/5 curl, slightly larger curl, or greater proportion of curl, would be in the 6-year range, with about 50 fewer rams per year. And a full curl regulation requires rams to age a couple more years before they become legal for harvest, and with an average age of 7 to 8 years old in that distribution. So in recent years, the figure here illustrates the resident and non-resident hunting age structure. So the number harvested on the left, as well as the age of that for each age class. So about, what's that, 72% of sheep in the last couple of years have been harvested in either the 6, 7, or 8-year age class, with the oldest rams being 14 years old in recent years. But as expected, this size structured harvest model, harvest system, results in an expected yield of size and age of sheep, and with this also illustrating that the resident hunters are
slow down. They're up here, Dad. It gets you.
Harvesting larger and older rams than the commercial outfitted harvested animals. So we can use this to simulate outcomes of harvest rates. And an example of that is illustrated by this figure. We've used simulated harvest outcomes or harvest rates to fit the model to an observed harvest age. And from that, this figure illustrates the proportion of the harvest that could be harvested if all were harvested at 4 years old. The 4-year-old sheep could, if you harvested every legal 4-year-old sheep or every legal 4-year-old sheep the first year it became legal, they would comprise a maximum of about 5% of the total proportion of harvest, assuming that we're harvesting about 175 rams per year. But the realized harvest rate is less than half. It's only about 25% escapement in this example. Of the 5-year-old rams, about half of them are being harvested. So these red dots indicate that where available, the proportion of the harvest that is legal to be harvested, we can estimate the harvest rate of each age class, and we can do that by each of those 4 regions in Alberta. So we're working to refine this analysis, but the management objective, as stated in the 1993 management plan, was to harvest about half the available rams each year and allow half of them to escape. And so somebody's not muted on the back end there. So could you please mute? But as expected, these older aged rams form a very small part of the population because typically they're harvested earlier, but we're working to improve sample sizes, and each year we increase sample sizes by about 160, maybe 180 rams a year is what we're able to increase sample sizes. So right now we have 733 in this analysis, and we're adding close to 200 per year, but we have some backlogged animals that we're going to be remeasuring, and others that we haven't yet added to this. So we hope that, potentially by the end of next year, we could have this over 1,000 rams in these data sets to continue to work with. So in discussion, how does this relate to a management objective? Well, horn-based and curl-based licensed harvest systems, they maximize hunter participation. 2,500, 2,600, up to 3,000 hunters can participate in the hunt with a low success rate and have the opportunity to go each year and maintain a desired and sustainable management objective and status of the population. In 1972, hunters were asked if they were satisfied in some public engagement, and at that time they were satisfied with the current opportunities afforded by the 4-5 curl regulation. And more recently, in 2025, we conducted a small sample where hunters again were still satisfied with the size and age and hunting opportunities that are afforded by this licensing system. But the management objectives we're currently meeting our management objectives, actually not even achieving the harvest rate that's desired. We're actually harvesting, by our estimation, 26 to 44% of the available animals. But that has to be not conditioned, but there's a consideration there that we're dealing with an open population. So there are no question sheep from protected areas, provincial protected areas, or national parks areas that are contributing to the harvest of sheep in the huntable landscape, and some of the harvest rates would appear biased low because we know we're harvesting animals that are in this open population that are moving into these areas. So where from here, we're currently in the process of developing an integrated management system with Speedgoat Wildlife Solutions, and which involves the development of a population model that will help refine some of the analysis and modeling to enhance the utility of compulsory registration monitoring systems that can inform our establishment of management objectives, or and also harvest rate, which in the future could lead to some ability to estimate population. But for now, we're refining analysis for the current objectives, and we'll see where this can take us to see what the full utility of the information can be. But we have been in discussions. We've presented this information to previous presentations, both publicly in a variety of means, with Wild Sheep Foundation members, as well as with the Northern Wild Sheep and Goat Council in Alaska last year. But since then, some other jurisdictions that have seen these presentations have reached out to us and are interested in the protocols that we have, and how measuring their sheep could help them understand what the relationship is, or how horns grow in their populations. So we're happy to talk to other jurisdictions if they want to reach out and ask some questions. But and specific to the integrated management system, we do have ability to incorporate RAM movement and spatial analysis to better define populations, which will help further accurize our estimates of harvest rate. But there is also other opportunities for the potential to develop tools for hunters to provide field-based observations of animals to further integrate into our integrated management systems and integrated population models. So we'll continue to promote awareness of the methods that we're using here, and refine these, and plan to update in the future when when ready. So with that, happy to take any questions, or we can hold them for after. But I do want to indicate that Nils Anderson is one of the big game allocation biologists that presented this at the Northern Wild Sheep and Goat Council last year, and he's been integral to the this project and preparation of all aspects of the initiative. So with that, Taylor, Amanda, I turn it back over to you.
Absolutely. Thank you, Grant. Really appreciate you and what you presented there. Taylor, I'm going to have you take it over now. And Grant, you might have to stop your sharing your screen. Oh, perfect. Again.
Okay, new share.
We're good to go. Thank you, Taylor.
Does that look good, Amanda?
It looks great.
Awesome. Thanks, Amanda, and thanks, Grant, for that presentation, and everybody for being here today. I'm going to be talking to you guys a little bit about some of the work that I did with some folks across Western North America a handful of years ago as part of my master's work, trying to understand how hunting influences horn size across their range. And so understanding how wild populations respond to change is one of the most important questions in wildlife management. And around the globe, a lot of the change that we see is a direct result of humans. So if that's something from habitat degradation to increased global temperatures, high levels of pollution, or unsustainable harvest, these things all have the ability to influence wild populations to varying degrees. And concern regarding the evolutionary response of wild populations to harvest has gained increased concern from the public, as well as wildlife managers and researchers over the past few decades. And this is because if we're selecting for a certain kind of trait like body size or horn size, we can cause evolutionary changes if we're removing enough animals from the population who possess that trait. And for ungulates, the primary concern here is focused on horns and antlers. Horns and antlers are often what we're selecting for and what we're valuing as hunters, and selection for males that are big and impressive can occur relatively often. So there's concern that if we're removing those animals who are growing rapidly and growing those really big and impressive horns, that we might be causing evolutionary changes through time. And this is important because horns can be both biologically and sociologically important. Biologically, they're indicators of individual quality. They can be indicators of sperm count, reproductive success and how impressive a male is to potential mates. And sociologically, we as humans care about them. We value the size of weaponries, and trophy animals are often what we're selecting for by hunters. And because of that selection, it's important for us to understand if how we are managing and regulating harvest is sustainable and if our harvest practices are influencing the size of weaponry in deleterious ways through time, so we can mitigate those potential consequences. And specifically in bighorn sheep, there has been shown to be genetically based reductions in horn size over time. Now, this is in a population that faces highly selective and intensive harvest. And they've shown pretty clearly that when we are selecting and intensively harvesting animals, we can see pretty significant reductions in horn size through time. But it's important to recognize that how we manage sheep and big game generally across North America can be super variable. And so it's important for us to understand how our harvest practices and how differences in harvest practices might influence some of these trends that we see. And to do that, we have to understand some of these things that Grant was just talking about: age, nutrition, and genetics. So if we want to know how age and horn size is changing, we have to look at the factors that influence how horns grow. So as males get older, they almost always get larger horns, with the exception of brooming. Nutrition can also play a pretty critical role. So we see that nutrition during the year of birth, as well as the year they're growing their horns, can play an important role in how big a male becomes. And then when all else is held equal, genetics plays an important role. So a father who has large horns is going to give birth to a son that has large horns. And to kind of dig into how we might be seeing changes in horn size at the population level across different populations, we wanted to test some hypotheses that really depended on this horn growth curve. And so this is just a theoretical curve that shows, as animals are getting older, how their horns are growing. And you can see that in those younger age classes, from 0 to 7 or 8 years old, we see that more rapid growth. And then as they're getting into those older age classes, it starts to really kind of level off. And so we wanted to test 3 primary hypotheses related to how harvest might influence horn size of populations. The first is a shifting age structure, the second is environmental effects, and the third is selective harvest. So the shifting age structure hypothesis really just says that as harvest becomes intensive enough, we should see changes in the age structure of populations through time. So if we remove enough animals from the population, we're going to see declines in the number of those older animals that are there. And it just means that the age structure is shifting to having a higher number of young rams. If this happens, we might expect that the average age of a harvested animal is going to decline, through time. And with that decline in average age, we're also going to see a reduction in mean horn size. But this isn't an evolutionary change or a genetic change. This is just because we're harvesting younger males. Now, the second way that this horn growth curve might change is through environmental effects, nutrition during different stages of an animal's life. And so we might expect to see that under poor environmental conditions, animals are going to be growing slower or smaller horns throughout their lives compared to animals who are exposed to favorable environmental conditions. So under poor environmental conditions, a 7-year-old might have significantly smaller horns than a 7-year-old who's exposed to really good nutrition. And then finally, if we account for age and the environment, the last thing that could be playing a role is that selective harvest. And the selective harvest hypothesis really says that if we're removing those really fast, large growing and impressive males, we might be causing some kind of genetic change in the population through time. And if this is occurring, we might expect that those horn growth curves are going to become depressed through time. So an animal that we saw at 7 years old in 1980 might be significantly larger than one we see in the early 2000s. It's important to note that these 3 hypotheses aren't mutually exclusive. We could see none, one, or all of these operating in a population. And so back in 2015, I started my master's and I worked with a lot of folks across North America to look at how horn size of two subspecies, Rocky Mountain bighorn sheep and desert bighorn sheep, changed across their range. And so this is kind of a 1,000-foot view. We were looking at a lot of populations to just kind of try to understand if we could identify changes that were occurring from those three different mechanisms: age, nutrition, and genetics, and understand if they're related to how we're harvesting bighorn sheep. And so we're using a lot of the data that Grant just talked about that's been collected by wildlife management agencies since, in some instances, as early as the 1950s, where we're getting those age measurements from annuli, as well as those horn size measurements. And this differs based on different agencies and what they collect, but at a minimum, almost all agencies are collecting that base circumference as well as horn length. So I'm going to go through some of the results that we found across mountain sheep range, but before I do that, I'm going to kind of walk through what the results are going to mean. So the first thing that we did is we identified population level changes. So this was just looking at how does the average horn size and the average age of harvested animals change through time. This doesn't tell us if there are genetic changes or not, just if there's reductions in the size of horns at the population level. But to understand if there are changes in those horn growth curves, the next thing that we did was we modeled the horn growth curves of cohorts born from 1981 until 2004. So this work was published in 2018, and we had data up until about 2015 and 2016 was the last of our data that we included in these analyses. And so those cohorts from 2004, we started at we ended at 2004 so that we could allow them to grow that full lifespan up until our data ended in 2015. And so what we did was predicted out these horn growth curves for these different cohorts. And then we looked at what the average age of a 7-year-old was from those different cohorts. And then we could see if those 7-year-old ages or the 7-year-old horn sizes were changing across these different generations. And then finally, we did account for those environmental effects. So we used remotely sensed data to account for forage quality, precipitation, winter severity, to see if that also influenced how those horn growth curves were changing. So, for example, if we look at a hunt unit in Alberta, we can see that if we just look at the average horn size of harvested males through time, we're not seeing a significant change. It's actually pretty level. But if we look at the average age, we do see that it's increasing pretty significantly from 1980 until around 2010. And then if we look at those horn growth curves, we see that there is a significant reduction in horn size. So these darker curves at the top represent cohorts from the early part of the study in the 1980s, and those green cohorts are later in the study. And you can kind of see that gradient of change that's occurring. And we also see that if we pull out those 7-year-olds, we do see a significant decline. Alternatively, if we look at some hunt areas in Colorado, we see that there is a decline at the population level from 1983 until 2005, but that's accompanied by a subsequent decline in the average age. And if we look at those horn growth curves, we're not seeing that clear pattern of change that we did in Alberta. And when we pull out those 7-year-olds, we see that there's not actually a change in how horns are growing. We're just seeing smaller horns because younger males are being harvested. And so when we look at this across all of North America, we see that about a quarter of the populations had declines in the horn size at the population level. 8% of those populations also had declines in the average age. And then when we modeled those predicted horn growth curves and looked at how 7-year-olds were changing, we did see about a quarter of those populations had significant declines in those horn growth curves through time. But some of that was accounted for by looking at the environment. So that number dropped slightly to 22% after we took into account those environmental effects. And so to kind of bring it back to these three hypotheses, we did find support for that shifting age structure. we were seeing declines at the population level that could be explained by changes in the age of those harvested animals that were being harvested from populations. We also saw that the environment did account for some of those declines in the horn growth curves that we were seeing. And then finally, after accounting for both age and the environment, we still did see that 22% of the populations had a significant decline in horn size through time. And this means that we can kind of use this information to dig a little bit deeper into those areas where we might be seeing changes and try to understand what might be causing those changes with a finer scale approach. The work we were doing here was really trying to look at broad scale, large, just general trends that were occurring so that managers could use that information to do a little bit more targeted work to understand what's going on in different populations. And Amanda mentioned this at the beginning, but all of the work I do is hugely collaborative. So I wouldn't have been able to do this without the support of many of my co-authors, as well as all of the folks who provided data and funding for this work. Thank you.
Excellent. Thank you so much, Taylor. That was fabulous. We will now open it up for questions. So feel free to unmute. We also have several folks here at the Sheep Center. So I'd like to encourage you all at this time to ask questions.
Pretty self-explanatory, actually.
Yeah, a lot of data there.
A lot. But interesting. very
Yeah,
interesting. But not surprising with the decline in heads and trophies and horns and stuff.
Yeah, it's interesting now. Like Taylor, thanks for your presentation. We're able to now describe differences in horn growth by ecoregion in the province, with the largest sheep coming out of the Cattleman area as well as southern Alberta. Those are the areas that have the largest. I didn't speak to it, but the largest horn bases and the largest rams. Incidentally, the sheep in the south are typically where we see our largest horn curl diameters. So, we're able to describe how horn growth varies through the province. But what surprised us is that it's the rams with the tightest curl, which are not actually the largest rams. It's the ones with the tightest curl, so the smallest diameter curl, that have the fastest growing horns, which are often not the largest sheep that are being enabled to be harvested first. But no doubt, the fastest growing rams are the ones that have the highest risk of being harvested, because they achieve that at an earlier age, and they then are exposed to more years of harvest if they're in the huntable land base. It surprised me when I looked through some of the historical data and tried to remeasure some sheep. I've seen errors of up to 4 years of age difference between the actual age and the previously reported age of rams. And we wanted to be certain moving forward as to what these relationships were. And when we're remeasuring the sheep now, we're still seeing that they're age biased, and in several instances, even if they get the same age, they're using the wrong annuli as the age, or they're not using the right protocol for aging. So, if any analysis based on a specific annuli does have the potential for error. To what degree, I can't quantify it with large sample sizes. I do intend to go out and remeasure a couple hundred more rams. So in the future, Nils and I will be able to speak to this, to some of the error in remeasured and re-aged animals. But the short story is, when you have 150 untrained people, maybe 200 untrained people, trying to age something that they have interest in or no interest in, there's wide differences in the age estimation, where most people want their animals to be older. And I would say the most common, so they're trying to make them older, and they're also often missing the first annulus if it's present, and if it's broom, they're also missing it then. And they're often missing, on the oldest sheep, they're missing annuli as they're stacked in the small grooves within the closer to the horn base in the last couple of centimeters or inches of the horn. So, we're trying to apply and put better estimates to the application of a horn based harvest system. So
Thank you for that, Grant. And we have a question online here. They ask, what is the change in environment?
the major change in environment in Alberta in two places, or I'll say all four. In the Chapman area, there's extensive coal mines that have been reclaimed to have non-native forage, and in their mining process and in the reclamation process, create an environment that has early cereal habitat that have artificial forages that contribute to a higher plane of nutrition. So that's one example where we see, especially those catamarans, they have huge first, second annulus circumferences. They're way larger than anywhere else in the province, and they're tighter curled than the southern rams. In the farthest north end of the province, in that map, those are the tightest curls, and it's the hardest winter. But it really surprised us that because of that, they were the sheep that were able to reach a greater proportion of curl very early. And in southern Alberta, once you get to the Bow River, so Calgary area and south to Montana, that's where the mildest winters are. Relative to the far north of Alberta, northern Alberta would have 2 months more winter than Calgary and these southern ranges, and where these sheep can winter at low elevation where there's essentially no snow and exceptional forage production. So they're, body size, they're exceptionally larger. The other interesting thing that we're seeing is that about I think the Kenow fire was a national park area fire in Waterton National Park, and that burned in 2017 September. And now we're starting to see rams born after the fire, and it's a landscape level exceptional sheep habitat prior to the burn, and now it's landscape level burned. It's actually an area where the former world record came from, and now we're starting to see sheep. For example, this past fall, we had a 6-year-old ram that was 188 inches in score or points. It was 39 inches long, and it was only 6 years old. And so they're world record trajectory sheep in the best habitat. And as the outliers, we'll call them, the largest sheep as you move throughout the years that are, let's say, young sheep that are the largest. This year we had one that was 4 years old, 4.5 years old at the time of harvest. And it was about 4 inches greater than legal, or 3 inches greater than the 4/5 curl. And it had 15.5-inch bases at 4 years old. That's a world record trajectory sheep. And there's others examples of that, but they all occur in southern Alberta in the mild Chinook affected winter ranges in the south, or potentially those in Waterton area that are benefiting from landscape level habitat restoration through restoring montane grasslands. So
Great, thank you. More questions?
Yeah, I may try a question. So I think like when I was paying attention like 5 or more years ago, I think the general feeling in Alberta was that we were shooting rams that were mostly too young, and there was some effort done to demonstrate that horn size was declining because of that, and we had a quite active discussion about what that would mean for regulation changes. This remeasuring effort, and kudos for doing that. I think I've tried to remeasure 1 or 2 or 3 right at the beginning of that effort, and it's quite the it's taken a lot of time to do that. So great job on that. But now that we have these remeasured data, do we have a different vision on what's happening in Alberta, and how would that reflect potential changes in regulations in the future?
yeah, thanks, Franz. Alberta's not considering any change to the current hunting regulations that, like I say, have been in place since 1968 with the 4/5 horn curl. You know, it's been 30, 55 years of that regulation. A lot of things have changed in that time period, but we're not currently intending to make any regulation changes. We are interested in updating the management plan, but a timeline for when that will occur is not hasn't been committed to. Our intentions here were to take an opportunity to collect the best data we can, so that when we get to any sort of discussion of management objectives, that we can quantify where we are today, and how that relates to other science that's available and stakeholder desires when we're considering what the best approach is moving forward. But at the moment, we are not considering any changes to the current approach. So, thanks, Franz.
Thanks.
Anyone else? Questions, comments, overall thoughts? Just
I'll ask a question here. Why is there just one area in southern Alberta that is a trophy, or pardon me, a full curl zone?
Okay. The full curl regulation is in place south of Highway 3, which only applies to WMUs 400 and I think it's 303. And those are in the mid 90s, there was what we think is a Mycoplasma ovipneumonia type die-off of sheep in the Waterton Front WMU 400. And in response to that, the full curl regulation was implemented in those WMUs, and it hasn't been considered to be expanded anywhere else in Alberta, or isn't being considered at the moment. I wasn't involved at that specific time, so I can't quote the particulars of why it was only those two, but it was related to the enabling recovery of the population after the die-off occurred.
And have we seen the population recover since that initiative in the early 90s?
Yes, the last time I flew and led the population survey for sheep management area 1 and 2, which encompasses that WME 400, that area, it was the highest ever recorded number of bighorns in 2018 ever historically available. So there were some considerations with that survey, though, that it was a severe winter, or a moderately severe winter, and with deep snow, and so sightability of sheep on those winter ranges that we conduct was exceptional, and sheep were constrained to a very small area, an abnormally small area. So it could be that we actually just detected more, and that there wasn't actually a true that it was because our aerial surveys at that time were not corrected for sightability. So it's not a population estimate. What it was a minimum total count on the identified winter ranges, and we only fly winter ranges that have greater than 20 sheep consistently on them. So succinctly, yes, they have recovered compared to previous surveys of minimum total count of that type. But what are they today? We haven't surveyed since, so it's been about 7 years, and our counterparts in department in the environment and protected area within the Alberta government are responsible for monitoring now. The hunting and fishing branch is involved but not responsible for that. So I'm not sure when the next survey would be, but we as a government prioritized the collection of this information to help inform management before we further invested into additional aerial surveys.
Can you share anything on the disease outbreak in the sheep around the Sheep River Sanctuary and the the call that happened there, I believe it was last year, and this just the status of how the herd is doing in that area?
Yeah, technically that's the responsibility of environment protected areas. I was the operations chief that led the response to that Movi outbreak, and it was formerly my management district before I took over provincial oversight. So, in short, we predicted that area was high risk for a Movi infection. We collaborated with the Wild Sheep Foundation and the University of Alberta's Boyce Lab to deploy extensive collars in southern Alberta, including collaboration with Waterton National Park and Banff National Park. And only 1 year after the deployment of the collars, one of the collared rams was killed by a cougar, and then several others were found dead nearby. And it was determined that there was a contagious pneumonia event that was occurring. And based on our consultation with the joining jurisdictions and the Wild Sheep Working Group and the WAFWA guidelines, we coordinated a response that contained those animals to, it was about 21 individuals, of which we had 6 of them have lethally removed. The remainder died or were never found, and we were able to successfully contain those animals, that outbreak, to not infect the 90 some odd bighorn sheep that were only about 3 kilometers away in their winter range, but just happened to be on a different mountain. So it's the only time that I'm aware of that an outbreak has been contained in that manner, and all that response occurred in a very short amount of time. And it's as far as recovery goes of that population, the ongoing monitoring and collaring that was resulted from that outbreak has not detected any further infected individuals or symptomatic individuals, and we continue to swab every sheep that comes into our offices for registration. So I'm not aware of any population surveys for that specific site. So I can't answer that as I'm not aware if there is any information available. But that population isn't hunted, so it's not considered for our allocation per se.
Okay. Well, thanks for that info. It's very detailed and interesting. Thank you. How often do sheep surveys happen in Alberta?
Historically, they may have happened about every 5 years, but to conduct a sheep survey, it's very time consuming and expensive. So to count 2,500 sheep, it would take 40 hours of rotary time and several months worth of prep plus analysis. So at $2,000 an hour for rotor wings. So they're very expensive surveys. And in recent years, they haven't been surveyed as much as they have been in the previous few decades. We've focused our management efforts on, disease testing containing Movi, better registration information, responding to that outbreak. So we're and then the ability to estimate populations and harvest rates are enabled by this sort of work. And so we're haven't prioritized those surveys because we're focusing on other elements that we think have a greater long-term value. In addition to this project, we are working with our department and other departments and collaborators on prescribed burn programs, mechanical habitat enhancement, disease testing, risk of contact with Mycoplasma ovipneumonia, to name a few projects.
Great, thank you. And we are getting on the hour, so if there's any more questions, I'd encourage you to ask them quickly.
Hi. Can you guys hear me?
Yes.
Okay, perfect. I just have a question about in the full curl zone, how many how many non-legal, I guess, like full curl rams have been taken since that program started, or like per year average, or does that happen? Or do they get reported, I guess?
Yeah, certainly all unlawful harvest is routed through our enforcement, our sheriff's division. public safety and enforcement services. And as far as an average goes, it would be probably less than one, or one per year, or less than one. I know of only one this year that was short in that area, and it was a one very similar to that big one that I mentioned, but it didn't quite meet the regulation, and therefore is now property of the Crown.
So it's been seen as a pretty effective way to manage the population in those zones, then, you'd say?
Yeah, as the data shows, the horns grow predictably, and when communicated clearly, the hunters are able to let's call it estimate that line and trim that regulation without it becoming unlawful, and the average length past legal. I think the last time I looked at it was about 9 centimeters over the legal line for 4/5 curl. For full curl, I can't quote what it is, but I would say in the full curl zones, it would be typically less than 1.5 inches to 2 inches. But we do get some rams that are very large, well, in other WMUs in the province, and we're able to, if they're greater than full curl, we're measuring all of those points within the proportion of curl for every sheep that we collect. So
Thank you so much. I appreciate your answer. Just one more quick question. So would you say that in the full curl zones, it's less likely for hunter error than the 3 curl zones to shoot a non-legal ram? Does that make sense, that question?
I think I understand the question that, what's the probability of somebody accidentally shooting a ram that's short under 1 curl versus the other, which relates to their ability to accurately estimate that line or the regulation in the field under hunting circumstances. And I discourage anybody from harvesting anything that they don't know with certainty that it meets those lines, and we clearly communicate them. We published the registration procedures that have been online for 4 years, and I encourage folks to get themselves a photography app for their spotting scopes to ensure that they're meeting those regulations, because it's very undesirable to meet under those circumstances in our sheriff's offices.
Perfect. Thank you, Grant. Have a good night.
All right, well, I just want to wrap
Yeah,
up. Go ahead, Grant.
Oh, we have about a 60-day season for most of the province under this general regulation. So season starting either August 25th or September 5th, running to the end of October. Then we have some late seasons under special licenses that start. But when you look at the results of this data and you compare them to some of the Montana Unlimiteds that have a similar regulation, although their curl restriction would be anywhere from the back of the eye to the front of the eye, which is it's between 3/4 and 4/5. They find that their average age harvested is slightly younger than ours, about a year, which is consistent with our horn growth relationships, and that they have about the same length of season in place before the quotas are met, and then they close those seasons. So yeah, so I don't know how this data would compare to other jurisdictions, because nobody else is taking the same measurements we are, but we're happy to share our protocols if there are agencies or regions that want to add to this data set.
Grant, you can hear me here. I maybe just got a quick question for you. Just in regards to some of those sheep becoming so big at such a young age, we got 4-year-old rams that are legal and have big potential, but they don't get the opportunity to maybe spend as long in the wild and breed and push on their genetics. Is there ever been talks about going strictly based on age, just so those heavy rams that are young and would go to be, possible record holders and stuff, that they get the chance to actually breed and be in the wildlife long enough to make that happen before they're taken as a 4-year-old, for example? Has there ever been talk of shooting based on age instead of size?
A short answer is no. That's many folks have suggested it, and when I have, like, I deal with 50 rams a year in my office that are hunter harvested that I register per year, and I ask every hunter to age it before they hand it over, and I would say 90% of those individuals have been wrong, including outfitters, guides, folks that thought they were really good hunters or had good knowledge of aging. And then we pull out the Canadian Mountain Network's aging guide, which is exceptional, that Marco helped develop. And we explain how to age a sheep properly in hand. And they quite quickly realize that to harvest based on an age on a bighorn, which is quite different than a thinhorn stone or doll, is not feasible, and I would never recommend it. If you did move to a system like that as a jurisdiction, you would have extremely high non-compliance, which is what I'm told British Columbia is currently having many difficulties with their stone sheep. But you know, for doll sheep, it's quite easy to estimate age structure that way on a thinhorn, and but most of the rams being harvested are older than 8. They're not harvesting a true 8-year-old right on the line. So in an age-based regulation. So Alberta is not considering that. And I don't recommend any jurisdiction ever consider it for bighorns, because it's just that difficult, especially as you get into the 7, 8, 9, 10-year-old age categories. And even where there's some, you know, significant variations in annuli or cessations in horn growth in midsummer that appear like they're annuli, but they're not. And I don't need more sheep in my collection that are unlawful or have been seized.
Thanks, I appreciate that. I guess it's just a different outlook, but it definitely makes sense. It's too hard in the field with hunter ability to start aging them. So it makes sense to stick with the system. Thanks for answering that.
All
Yep.
right. Thank you so much, Grant, for all of the research that you have done. Incredible. Tayler, thank you. I know both of your schedules are pretty tight, so I really appreciate you zooming in with us today. Again, this is Amanda Verhill with the National Bighorn Sheep Center, and we're all about education. So if you have any other ideas for webinars, please reach out. This webinar will be recorded, and we'll put some information in the comments on our YouTube channel about the associated documents then relating to the chat here that was in the Zoom call. So the document's name in the comments, Grant in the future. So thank you again for all of you and all the collaborative efforts here at Wild Sheep Foundation. I just can't say enough. I think this is fantastic, and let's continue to do great research. So thank you and good night.
Thank you.
Good night.